Hello, I'm Adam Czajka, and together with my colleagues Aidan Boyd, Daniel Moreira, and Kevin Bowyer, we're happy to offer this tutorial on human-machine pairing to improve computer vision. I cannot be with you in Hawaii right now, but I'm prepared. I have my Hawaiian shirt on me. And also I'm a little bit jealous because in Indiana, where the University of Notre Dame is located, today is snowing the whole day. So when I'm recording this video for you, so maybe next time, hopefully next time, I will be there. So the goal of this tutorial is to share with you some of our observations and conclusions related to incorporation of human intelligence into training strategies, modern deep learning-based models. That was done because we observed very poor generalization capabilities of these models, especially when trained to solve a difficult task of detection of different attack types in biometrics. And that was related to iris recognition and also face recognition. So in iris recognition, we have multiple attacks possible in face recognition as well. And the most known recently are, of course, deepfakes. So when we train these models on something that we knew or attack types that were known, the performance of these models are actually close to perfect. When something changes, so the attack type is completely different, these models actually perform close to random chance. There's a huge gap between these two situations. The question is if we can improve that situation, what to do, what kind of extra information we could use to improve that situation. And this extra information may come from human intelligence. Humans are actually performing maybe not perfectly in this kind of tasks, but we have capabilities to generalize on unknown samples way better than deep learning, at least actual current deep learning models. The context for today is visual biometrics, iris recognition, and presentation attack detection. So these are two different topics close to our research, close to our expertise, and this is where we actually are applying these models. None of the methods presented today are actually specific to biometrics or biometric presentation attack detection. They are specific to problems in which humans can give us something, in which humans can provide some extra information. So, so visual recognition tasks that are beyond human perception are probably not good, but there are many visual recognition tasks in which humans actually performing pretty well. So in these situations, these algorithms, this idea should be applicable. We are doing this for three different reasons. So the first reason is increased generalization, as I said. This is what we aim for, just to react accordingly to new attack types, unknown attack types that of course happen all the time. But also the other reasons why we are doing this is higher trustworthiness of AI models. This is what is recently quite important, not to only have just the accurate model, but also the model that we can trust. And the third goal is to assist humans with decision-making. So these AI models perform better. They react better to unknown samples. Then they can probably give some hints to human examiners who are solving the visual task and help them in making the final decision or making better final decisions. So the first step is, of course, to have some known visual inputs for initial training. And we have this is where we are starting with. So we have a trained model. And we have, of course, humans that are trained in a sense that we saw a lot of different visual objects, and we did a lot of different visual recognition tasks. So we have some prior knowledge about different recognition domains. What is recently quite useful and important is that, as I said, these AI models can support human experts. So we can additionally may see some interpretations of decisions that may additionally help humans in decision making. But what is problematic is when some unknown visual inputs show up. So then, as I said, AI models perform very badly. Humans, in many of these tasks, perform slightly better. It depends on the task, but our generalization capabilities are on average higher than generalization capabilities observed for AI models today. So the question is how to use that, how to take some of this knowledge, some of this intelligence, and transfer this to training strategies. And this is the second part of the loop, or the cycle, human-machine supervision cycle, that we coined for this research here shown in this slide. So today's tutorial will be focused on this part: how to use human intelligence, human perception to guide networks or to guide the models towards better generalization. That's what the aim for today is. And we will have 5 different sections, 4 speakers, but 5 different sections. The first section will be first talk will be given by Kevin Bowyer, who will make a nice introduction to iris recognition, just to explain what it is, why it is important, what kind of visual task we're solving there. Then we will switch to Daniel Moreira, who will explain how humans perform in this task. Iris recognition is not something that humans are experts in. We are experts in face recognition, maybe. We're experts in general object recognition, but iris recognition is quite specific, which is good for us, actually, because we wanted also to show that these methods work, or this idea works, even if humans are not experts in a given task, which is promising. I will be talking as the next speaker, and I will show a non-deep learning based method that can be built based on human salience. This will be based on human-driven binary statistical image features that we used actually to build special set of filters to perform iris recognition better than existing algorithms. And then we will go back to Kevin Bowyer, who will talk about presentation attack detection. So we will move from iris recognition to another topic, which is iris presentation attack detection. But the main component of his talk will be how to use human salience to modify the training data to guide the network towards better solution. That is very useful for black box models. So if we don't want to mess up with the network, all the loss functions or the architecture, and we have just a black box model, we can modify the training data in a special way using human salience to make the solution, the final solution, better. But if we want to deal with loss functions, and we have the opportunity to do that, Aidan Boyd will explain how we can use human salience in building a new type of loss function, which we call a cyborg. He will explain what the cyborg acronym means. So that's all for my introduction. I hope this tutorial will be useful for you. You will enjoy all the talks. I'm super happy to answer questions and interact with you, and I believe that all the speakers are very happy to answer all the questions. And of course, we are available after this tutorial to get further feedback from you, especially how these methods maybe work in your research task. That will be fantastic to see how actually ideas presented here applied to different tasks work. That would be great to see. Thank you so much. Enjoy the day, enjoy this tutorial, enjoy the weather in Hawaii, and hopefully see you somewhere soon. Now we will start with Kevin Bowyer, who will be giving the introduction to iris recognition.